Hello, Honors Pre-Calculus students, Mr. Cruzado. Today's learning target is to calculate various probabilities, and in the yellow box we have the probability of an event is the favorable outcomes over the total outcomes. A lot of times in probability there is more than one way of doing a problem, so we're going to look at these couple problems here. Part A, in a class of 20 males and 11 females, if 2 students are chosen at random, what is the probability of choosing 2 females? So whenever possible, I use combinations over combinations. So in this particular problem, there are 11 females and I want to choose 2 of them. And I'm going to divide by the total, there are 31, and I have to choose 2 of the students. And then I'm going to pick up my calculator and type that into my calculator. So on the Casio, you would type in 11 choose 2 divided by 31 choose 2, and you can see that decimal on the screen, 0.1183. And on the TI, you would type it in the same way, 11 choose 2 divide by 31 choose 2, and you get the same decimal. We showed you in the last unit where the combination button was. So the answer to this problem is 0.1183. For part B of the problem, I want 2 males. So out of the 20 males, I need to choose 2 of them and divide by 31 choose 2. So as I mentioned, whenever possible, I do combinations over combinations. Doing this on my calculator, I get 0.4086. For part C of the problem, I want 1 male and 1 female. So you can do 20 choose 1 times 11 choose 1 and divide by the total 31 choose 2. Those are the total outcomes. Notice when you do this, the 20 and the 11 add up to 31, and the 1 and the 1 add up to 2. When you type this into your calculator, you get approximately 0.4731. As I mentioned, there are sometimes more than one way of doing a probability question. So a second way to do part A is you could draw 2 dashes. You want a female and a female. So to get a female, you have 11 out of 31 choices. It's implied without replacement, so then you have 10 out of 30. If you type that into your calculator, you will get the same answer. For part B, if you wanted to use the dash method, 2 males. So the probability of getting the first male is 20 out of 31. Second male would be 19 out of 30. Again, doing that on your calculator, you will get 0.4086. And you could do part C in a similar manner, but whenever possible, I actually just use combinations over combinations. So if you look at problems 2 and 3, it'd be my suggestion you pause the screen and try these problems on your own, and then check my answer. So for problem number 2, we want a committee of 3 independents. We see that there are 9 independents, so the favorable would be 9 choose 3. And then the total number of outcomes, I need to add the 11, the 15, and the 9. When you add those up, you get 35 people. So out of the 35 people, you can choose any 3 of them. Typing that into your calculator, you get 0.0128. In statistics, we tend to use 4 decimals, so I will do that throughout the lesson. For problem number 3, Wills and Max have 13 marbles in their collection, and there are various colors. Carly chooses 2 marbles. What's the probability that they're both royal blue? So there are 3 royal blue marbles, so the favorable outcomes would be 3 choose 2, divided by the total number of outcomes. Out of the 13 marbles, she needs to choose 2. And when you type this into your calculator, you get 0.0385. It'd be my suggestion you pause the screen and try problems 4, 5, and 6. For problem number 4, we want a committee of 4 people, and we want no Republicans. No Republicans means they're all Democrat or they're all independents. So out of the 19 people that I highlighted in blue, we want to choose 4 of them. That's the favorable outcomes. Divided by the total, there are 32 people. Choose 4. Typing that into the calculator, we get approximately 0.1078. For part B, again, we have Wills and Max with their marble collection. They want to choose, Carly wants to choose 4 marbles, all indigo. There are 8 indigo, so the favorable outcomes are 8 choose 4. The total number of outcomes, or the total number of possibilities, would be 15 choose 4. Typing that into your calculator, you're going to get 0.0513. For problem number 6, again, we have Wills and Max. They're going to choose 2 marbles, or Carly will. She wants a royal blue and an indigo. So out of the 6 royal blue, she needs to choose 1 of them. And out of the remaining 8 indigo, she needs to choose 1 of them. So 8 choose 1. So this is like the shirt and pants problem from the previous unit that we want to multiply them. A key word in this is and. In general, the word and does mean multiply. Divide by, there are 14 marbles, and she is choosing 2 of them. Typing this into your calculator, you get 0.3529. Again, I want to point out the 6 and the 8 add up to the 14. The 1 and the 1 add up to the 2. Some people like that idea. And just a little side note, if you're wondering why I chose those colors, desert sand starts with the letter D, so does Democrat. Royal blue starts with the letter R, so does Republican. And indigo starts with the letter I, so does Independent. So for coding purposes, I use this colors there. All right, take a look at number 7. Again, pause the screen and try this on your own. All right, for number 7, we want 1 indigo, and I may have misspelled that, and 2 royal blue. And there are 12 indigo. So out of the 12 marbles, she needs to choose 1 of them. Then she wants 2 royal blues, so out of 17, she needs to choose 2 of them. Again, it is multiply in there because of the word and. There are a total of 35 marbles, and she's choosing a group of 3. So the denominator would be 35 choose 3. Typing that into your calculator, you get 0.2494. Pause the screen and try problem number 8. So for problem number 8, we want 6 Democrats, so that'd be 14 choose 6. We want 2 Republicans, so that'd be 7 choose 2. 3 independents, there are 10 independents, so 10 choose 3. Again, the key word there connecting them is and, so I'm going to be multiplying those. And divide by the total, so when you add up the total number of Democrats, Republicans, and independents, you'll see that there are 31. And how many are we choosing? We're choosing 11 people in total. When you type that into your calculator, you get approximately 0.0894. I'm going to point out that these 3 yellow numbers add up to 31, and these blue numbers add up to 11. It's a nice way to check that you did the problem correctly in terms of making sure you chose the correct amount of people. All right, problem number 9 is a little different. It says at least 1 Democrat, and there are 2 ways you can do this problem. You can figure out 1 Democrat, you can figure out 2 Democrats, 3 Democrats, 4 Democrats, 5 Democrats, and 6 Democrats. So we want a committee of 6 people. So at least 1 means 1 Democrat, 2 Democrats, 3 Democrats, 4 Democrats, 5 Democrats, and 6 Democrats. And you could figure this out, and then you'd have 1, 2, 3, 4, 5, 6 numbers, and you would add all of those answers. But if you look to see what's missing, 0 Democrats. So an easier way of doing this problem is to use the complement. Since we know the probabilities add up to 1, you can do 1 minus the probability of the complement of at least one Democrat, and the complement of at least one Democrat is no Democrats. So an easy way when you see the words at least or at most is to think about the complement. You could do the blue problem and add up all 1, 2, 3, 4, 5, 6 answers, or you can use the concept of the complement since the probabilities add up to 1. So no Democrats, this would be 1 minus, well, there are 27 people that are not Democrats, these 14 and these 13. So out of the 27, you need to choose 6 of them. The favorable outcomes is 36, choose 6, because there are 36 people here. Typing this into your calculator, you get approximately 0.8480. So just to restate, you could figure out all 6 of these that I'm highlighting in green, figure out each of those probabilities, and then add them up. The alternative is what's missing. We have no Democrats is missing. So then you could figure out probability of no Democrats and subtract from 1. I'm going to just do this one example just to make sure you're clear. 4 Democrats. If you wanted 4 Democrats, you would do the following. It would be 9, choose 4. And then you need 2 more people. And those 2 other people have to be either independent or Republican. So it would be 27, choose 2. And then you would divide by the total, 36, choose 6. So you would have to figure out all 6 answers, and I did one of them in blue, and then add them all up. So it would be my suggestion you try problem number 10, pause the screen, and then come back after you have the answer. I'm going to pause here for a second. If you look at problem number 10, Wills and Max have 13 marbles, and they want to choose, or Carly wants to choose, a royal blue or an indigo. Let's think about all the different possibilities if she's choosing 2 marbles. So if you think about all the different possibilities for problem number 10, since there are 3 colors, she has 3 choices and 3 choices, so 3 times 3 is 9. And I listed them out for us here. So these are all the different possibilities if she's choosing a royal 2 marbles. We want a royal blue or an indigo. So if I want a royal blue or indigo, I want all 3 of these that I just highlighted in blue because they have an indigo. I want this one, it's got a royal blue, I got royal blue, I got another royal blue. I want this one that has an indigo, and I want this one that has a royal blue. So I want every combination there. Well, what's missing? 2 desert sand. So this is the idea of the complement again. So I'm going to do 1 minus the probability of 2 desert sand marbles. So that'll be 1 minus, there are 4 desert sands, so 4, choose 2. Divide by the total number of marbles, 13, choose 2. Doing that on a calculator, I get 0.9231. So this one is a little different than number 9, but it still uses the same concept of the complement. Let's take a look at number 7. What is the probability she chooses 2 of the same color? 2 of the same color means she gets 2 desert sand, 2 royal blues, or 2 indigos. So I'm going to put the word or here. For this particular problem, you actually do have to do 3 different problems. 2 desert sands, 2 royal blues, 2 indigos. So for the 2 desert sands, it's 4, choose 2. For the royal blues, it's 5, choose 2. And for the indigo, 8, choose 2. Now, the key word here is or. Remember, we talked about the word and in general means to multiply. In general, the word or means to add. So I'm going to add all those up and then divide by the total. There are 17 marbles, and she wants to choose 2 of them. Doing this in my calculator, I get 0.3231. 0.35. Let's go to the next page. My suggestion is you pause the screen and try the next couple problems on your own. Let's see how you did on problem number 12. If you look at part A, 17 choose 6 over 24 choose 6. For part B, 17 choose 5 times 7 choose 1 divided by 24 choose 6. And for part C, it says the probability at most 4 juniors. So what's missing? 5 juniors or 6 juniors. I'm highlighting that in yellow on the right-hand side. So for problem C, I had to figure out 5 juniors that I'm highlighting in blue. I had to figure out 6 juniors, which I'm highlighting in green. I would add those two up, and then I could use the complement concept. Go ahead and pause the screen and try 13 if you haven't already. Number 13 actually reverts back to the counting problems that we did in the earlier unit and all the different ways people could line up. So if I think about favorable over total, if I have 23 people in the class, there are 23 factorial ways that they can line up at the door. And now we want the freshmen to stand next to each other. So let's consider the 4 freshmen as a group. So we have 4 freshmen, you can think of them as a group. Then we have 19 other students. So how many objects are being lined up? 20. So it would be 20 factorial. But then as we discussed in the earlier unit, those 4 freshmen could be rearranged. So that would be 4 factorial. So the favorable outcomes are 20 factorial times 4 factorial. And the total number of outcomes, 23 factorial. That's 2.25 times 10 to the negative third. Pause the screen and try problem number 14. So in problem number 14, we again have 23 students lining up. 3 freshmen, 9 sophomores, 7 juniors, 4 seniors. They want to line up where each class must stand next to each other. So we got 1, 2, 3, 4 objects lining up. And then within each group, they could be rearranged. So the denominator, again, is 23 factorial. And for the freshmen, you have 3 factorial. Sophomores, 9 factorial. Juniors, 7 factorial. Seniors, 4 factorial. But if you think about these groups, how many ways can the groups be rearranged? Well, the groups could be rearranged 4 factorial, so you need another extra 4 factorial because the 4 groups could be rearranged 4 factorial ways. Typing that into the calculator, again, you get a small number, 2.44 times 10 to the negative 10th. I guess if you were to round in number 13, you could say 2.26 times 10 to the negative third. And this one here, if you were to round the 2 decimal places, is 2.45 times 10 to the negative 10. Due to time constraints, we are not going to cover number 15 and number 16 this year, so I'm going to cross those off.